The leave plan of room specialists has revealed that utilizing our new 101 billion toy it will likely always be. Before that, if all goes according to plan, the trip to Proxima B is expected to take about 20 years. However, realistically it will likely be a few years before we can even begin to confirm whether there is any life on that planet. The ongoing inquiry into whether we are truly alone in the universe persists, fueled by discoveries from the James Webb Space Telescope. This telescope has already found some incredibly intriguing phenomena far from Earth that might bring us closer to answering this question. Our quest for understanding our place and significance in the universe has always been central to human existence, generating countless media productions and theories over time. Our curiosity about the universe, along with our sense of loneliness, has driven us to constantly search for others, even if we are minuscule in the grand scale of things we might be drawing nearer to the answers we seek. But are they really the answers we want, or are they simply unsettling revelations? Join us as we explore the latest findings in the field of systems and exoplanets as we embark on a journey that may lead us to encounter something we are not ready to understand. In 2021, experts made a significant breakthrough, potentially one of the greatest discoveries in history, with the launch of the James Webb Space Telescope. A fascinating hypothetical question was raised regarding the capabilities of our technology. The question was whether in the future our telescopes could detect artificial light on another planet such as Proxima B, the closest exoplanet to Earth. Proxima B, located 4.2525 light-years away, was identified as having a permanent dayside and night side similar to our Moon. A hypothetical advanced civilization on Proxima B might harness energy from the day side and transfer it to the night side using photovoltaic cells, which convert sunlight into power. In a paper co-authored by Manis Ving and other scientists, it was demonstrated that an extensive array of solar panels on the day side could be linked to future telescopes. Since the James Webb Space Telescope JWST has been upgraded, it has enabled us to extend our search for artificial lights on exoplanets like Proxima B. The fact that the JWST was able to detect these lights in 2024 with its enhanced capabilities marks a revolutionary moment. The JWST may have located the very lights we've been searching for, potentially propelling us into a new phase of human exploration. Let's dive into the world of planets and exoplanets to understand how this discovery became possible. Since the dawn of written history, humans have pondered the vastness of the universe. Who are we? Where do we come from, and where are we headed? These questions are timeless but also exceedingly complex. As we continue to advance technologically, one wonders whether we are any closer to answering these questions. If you were to ask a scholar, they might claim that we are still at the very beginning of understanding our place in the universe. However, ask an astronomer the same question and they'll likely become enthusiastic, eager to share the latest findings made about the universe through the use of their advanced instruments. These tools, which are often overlooked by the general public, are in fact a direct reflection of human progress. We now have access to the universe, and it's time for us to push forward and harness the knowledge and technology that brings the cosmos within reach. One such advancement is the creation of the James Webb Space Telescope, JWST, which holds the key to answering some of the most fundamental questions humans have about our existence. The James Webb Space Telescope represents humanity's efforts to explore space and seek answers to age-old questions. Are we alone? What is our purpose, and where are we going? This powerful infrared telescope is already working to address these questions. But if you're wondering about Proxima B, it is sometimes referred to as Proxima Centauri B or Alpha Centauri B. This exoplanet is a super Earth and orbits an type star. You might be puzzled by the term super-Earth, but don't worry, this article will clarify. Everything super-Earths are planets that are larger than Earth but smaller than gas giants like Neptune and Uranus. They can consist of gas, rock, or a combination of both, and their sizes range from twice the mass of Earth to several times that of our planet. Proxima B is a super-Earth exoplanet, meaning it orbits outside of our solar system. The first hints of exoplanets emerged in 1917, but it wasn't until 1992 that the first confirmed discovery left experts astonished. Another exoplanet initially discovered in 1988 was confirmed in 2003. As of April 1, 2024, there are 5,653 confirmed exoplanets in 4,161 planetary systems, with 896 of those systems hosting more than one planet. Many of these exoplanets orbit around type stars. To understand type stars, it's essential to know that they are the smallest type of stars in the main sequence, often referred to as red dwarfs. These stars are incredibly common in the Milky Way, but their faint glow makes them hard to detect. Type stars have temperatures around 3,000 Kelvin, which is relatively cool compared to other stars. Proxima B's host star, Proxima Centauri, has a mass roughly equivalent to 1.07 times that of Earth. Interestingly, Proxima B only takes 11.22 days to complete one orbit around its star, which is much shorter than Earth's 365.25-day orbit. Proxima B star is quite faint, emitting only about 1.6% of the Sun's total luminosity in the visible light range. Its radiance is even lower, producing only 5 to 6% of the Sun's visible light output. Over 85% of the energy emitted by Proxima Centauri is in the form of infrared radiation. Proxima B orbits the star at a distance of about 0.045 to 0.056 astronomical units, much closer than Earth is to the Sun. Proxima B was first discovered in 2016, and you might wonder why this exoplanet, despite the existence of millions of other stars, planets, and galaxies, has garnered so much attention. There are a few key reasons for this. First, Proxima B is the closest known exoplanet to our Sun, located just 4.2 light-years away. While 4.2 light-years may seem like a vast distance, it is relatively small in the context of the entire universe. Proxima B is part of the Alpha Centauri system, a triple star system. Despite Proxima Centauri's faint luminosity, the Alpha Centauri system remains one of the brightest objects in the night sky, coming in just behind Sirius and Canopus. Perhaps the most fascinating aspect of Proxima B is that it may be habitable, as it lies within the habitable zone of its star. This zone is where liquid water could exist, raising the possibility of life. For these reasons, astronomers have been keen to explore the potential habitability of Proxima B and other exoplanets like it. This is where the James Webb Space Telescope comes into play. The JWST has 4 key objectives: to study the light from the first stars and galaxies formed after the Big Bang, to investigate the formation of stars and planetary systems, to understand the development of stars and planets, and to explore the origins of life. As the JWST continues to explore exoplanets like Proxima B, we are moving closer to achieving these goals, from searching for exoplanets to investigating extraterrestrial life. This quest is not merely about answering scientific questions, it's also a reflection of human curiosity. Throughout history, humans have been driven to explore, to seek, and to understand everything in our universe, both animate and inanimate. This insatiable curiosity led to the search for extraterrestrial intelligence SETI, an effort to find signs of life beyond Earth. SEI is one of humanity's most ambitious endeavors, likened to a game of cosmic hide-and-seek with our planet, searching the vast universe for any sign of intelligent life. The search for Extraterrestrial life began in the 1960s, when astronomer Frank Drake first detected radio signals from stars. Although this momentous discovery did not result in any contact with extraterrestrials, it marked the beginning of a significant effort to find such signals despite the challenges. The search continues, and recent advancements in technology such as the JWST are bringing us closer to potential breakthroughs as the James Webb Space Telescope continues to monitor exoplanets like Proxima B. There is growing hope that we may find concrete evidence of extraterrestrial life. If such evidence is found, it could change everything we know about life, intelligence, and the nature of the universe itself. Even if no direct evidence is found, the discovery of artificial signals or light from distant worlds would have profound implications, suggesting that intelligent life might be more common than previously thought. While the excitement of these discoveries is palpable, they also raise important questions about our reaction to such findings. How would we respond if we confirmed the existence of extraterrestrial life? Would we approach this discovery with curiosity, respect, and scientific rigor, or would it provoke fear and uncertainty? Humanity's history of reacting to groundbreaking revelations, especially those that challenge deeply held beliefs, has often been unpredictable. This leads to further moral and ethical considerations. If we were to encounter intelligent extraterrestrial life, what would our responsibilities be? What moral framework should guide our interactions with other forms of life, whether they are microbial or advanced? These questions are complex, and as we continue to explore the universe, they will likely become central to our understanding of our place within it. As we stand on the brink of potentially groundbreaking discoveries, the questions of ethics, responsibility, and our place in the cosmos become even more pressing. The encounter with extraterrestrial life, whether microbial or intelligent, would undoubtedly be one of the most profound events in human history. The very notion of discovering life beyond Earth challenges everything we know about biology, philosophy, and the concept of what it means to be human. Our approach to such a discovery will shape our future interactions with the cosmos and any other civilizations we may encounter. In addition to the moral and ethical considerations, there are practical concerns that must be addressed. How will we ensure that our interactions with extraterrestrial life are conducted in a manner that respects their autonomy, their way of life, and their environment? Could our presence, even in the form of passive observation, have unintended consequences for alien ecosystems or civilizations? Just as we have learned through history that human actions can have far-reaching impacts on our own planet's ecosystems, we must consider the possibility that our presence could disrupt the delicate balance of life elsewhere in the universe. These questions extend beyond the scientific community and touch upon philosophical, political, and cultural domains. The discovery of extraterrestrial life, especially intelligent life, would likely spark debates about the potential for cooperation, conflict, or even colonization. How should humanity prepare for the possibility of meeting beings whose existence and culture are so different from our own? Would the discovery unite us, or would it divide us as different factions and ideologies attempt to shape the narrative of what these discoveries mean for humanity's future? As we venture further into the unknown, the need for international collaboration will become ever more important. The search for life on other planets, the study of exoplanets, and the analysis of artificial signals or light may transcend national boundaries, demanding a unified effort across the globe. Just as we have cooperated in space exploration with the International Space Station and other initiatives, the search for extraterrestrial intelligence SETI may one day serve as a unifying force. The pursuit of knowledge is a global endeavor, and it is essential that we approach these new frontiers with spirit of collaboration, respect, and openness. At the same time, we must acknowledge that these discoveries could challenge long-held beliefs and frameworks that have shaped our understanding of the world. Science, philosophy, and religion may all be forced to reconsider their premises and adapt to a new reality in which humanity is not the only sentient or even the dominant form of life in the universe. Such a shift could alter our understanding of existence itself, what it means to be conscious, to be alive, to belong to a larger community of beings. These changes could redefine the way we view ourselves and our place in the vast cosmic expanse.